Hello, students. Greetings to you all. Hope you all are safe and doing good. It is nice to meet you all in this platform. So, let's move on to the motivational quote for the week. Success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do. It was said by Pele. Yes, my dear students, to get success, you need to do hard work, perseverance, learning, studying, sacrifice, and most of it, you need to love the work you are going to do. With this quote, we'll move on to today's class. So, in today's class, we are going into a new topic. As of now, we have completed four lessons: measurement, matter around us, plant physiology, and motion. In today's class, we are going to start the new lesson, Unit 11, Atomic Structure. So, topics to be concentrated in this session are introduction, discovery of nucleus, Rutherford atomic model, and Bose atomic model. So let us start with a small activity. Take a sheet of paper and a scissor. So now we are going to divide the paper into two halves. Okay. Further divide into halves. Further divide. So now we are going to cut the paper till you can say that I can't cut the paper furthermore. Okay. Have you done, students? Yes. So likewise, let us take a chalk piece. Okay. Now break it into two half. Further break it, and finally you will be getting a chalk powder. Can we able to still break it after it got powdered? No. Yes. So long years ago, a Greek philosopher named Democritus came up with an idea called atoms. It comes from a Greek word atomos, which means indivisible. So, according to Democritus, anything which is divided can be divided up to the stage when it reaches atoms. Atoms is the smallest indivisible unit. Nothing can be divided further atoms. So, everything in the world is made up of atoms. Many scientists was curious to find out the internal structure of an atom. They wanted to find out the particles present inside the atom and how these particles are arranged in an atom. For explaining this, many scientists proposed various atomic models. In 8th standard, you would have studied about Dalton atomic theory and J.J. Thomson model. Now we will see other two model which explains how a particles are arranged within an atom. Around the year 1911, a British scientist, Lord Ernest Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. This experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of atom in a more accurate manner. Rutherford performed an experiment in which he took alpha particles. So this is the setup of Rutherford model, okay? Alpha particles are positively charged particles. He projected these particles on the atom. He made these alpha particles to pass onto the gold foil. He found that most of the alpha particles passed through and few were deflected. Why did he took gold foil? This is because he wanted a very thin layer to perform the experiment, and gold can be made into a very thin sheet, and gold is the most malleable metal, and this would be the reason why he took gold foil to perform this experiment. So Rutherford first expected that all alpha particles would get deflected or bounce back. Since J.J. Thomson model says that atom is a solid positive sphere. As alpha particles too is positive, then of course they repel each other, since we know that like charges repel. But when he experimented it, he found that most of the alpha particles pass through the foil. Thus, he came into conclusion that the atoms contain large empty spaces, since most of the particles went straight to the gold foil without any deflection, which means the most of the space in an atom is empty. He also observed that some alpha particles were slightly deflected from their straight path and very few particles completely bounced back. Later, Rutherford generalized these results of alpha particle scattering experiment and suggested a model of the atom that is known as Rutherford's atomic model. According to this model, the atom contains large empty space. There is a positively charged mass at the center of the atom known as nucleus. The size of the nucleus of an atom is very small compared to the size of an atom. The electrons revolve around the nucleus in closed circular paths called orbits. An atom as a whole is electrically neutral, that is, the number of protons and electrons in an atom are equal. Rutherford model of atomic structure is just similar to the structure of the solar system. In an atom, the nucleus contains the main mass and the electrons revolve around it in the orbits. When we compare it with the solar system, the sun is at the center like nucleus and the planets revolve around the sun like the electrons revolve around the nucleus. And there are certain limitations in Rutherford's model. So, according to electromagnetic theory, a moving electron should accelerate and continuously lose energy. Due to the loss of energy, path of electron may reduce and finally the electron should fall into the nucleus. If it happens so, then atom becomes unstable. But in this case, atoms are stable. Thus, Rutherford model failed to explain the stability of an atom. Rutherford's one of the student was Neil Bohr. Bohr was extremely interested to study the structure of atom. But later on, when he saw Rutherford model, he was not convinced because according to the law of physics, if a charged body is in motion, then it radiates energy. So if electron which is negatively charged, it is moving around the nucleus, it continuously loses energy. Therefore, it moves closer and closer into nucleus and hence it should collide with the nucleus. So Rutherford model was not able to explain the stability of the atom. And Bohr explained it to Rutherford and Rutherford appreciated his student work and told him to study the structure further. Thus, Niels Bohr, a brilliant scientist, gave his atomic model in 1913. According to Niels Bohr model, the electrons revolve around the nucleus in definite orbits in which they do not radiate energy. The electrons which is closer to the nucleus, they are attracted towards the nucleus with greater force, and the electrons which are far away from the nucleus in the outer orbits, they are attracted towards the nucleus with lesser force. And so, if an electron closer to the nucleus is to be moved to an outer orbit, then it requires an energy to move from closer to the nucleus to an orbit which is away from nucleus. So now let us see the points given by the Bohr. So electron orbit the nucleus in certain fixed orbits that has the fixed amount of energy. He named the orbits as K, L, M, N shells. The orbits can also be called as shells. The orbits which is closest to the nucleus is the K shell. The second shell is the L shell. The third shell is the M shell, and it moves on. Bohr named these shells as energy shells or energy levels. Bohr related the energy of these orbits to their size. The lowest energy is found in the smallest orbit, that is closest to the nucleus. Then the second orbit has little higher energy when compared to the first orbit, and the outermost, being the largest or highest orbit, has the highest energy. We already saw that electrons need energy to move from one orbit to another. So, energy is absorbed or emitted when an electron moves from one orbit to another. It does not radiate energy on its own. That is, when it revolves in a particular orbit, then it doesn't radiate energy. Only if the electrons move from one orbit to another, it loses the energy. So let's see the limitations of Bohr model. There's only one limitation according to Bohr model. So the Bohr model was applicable only to hydrogen and hydrogen-like ions. For example, He plus, lithium 2 plus are the examples. It could not be extended to multi-electron nucleus. And that's it, my dear students. So we saw Rutherford's model and Neil Bohr models in today's class. So can we quickly review what we learned in class? It's time for review. So in today's class, we saw two atomic models. They are Rutherford atomic model and Bohr atomic model. What was the major advancement between the two models? Rutherford model was not able to explain the stability of an atom, but Bohr was able to explain the stability of an atom. According to his model, the electrons revolve in definite orbits in which they revolve without losing energy. Only if the electrons move from one orbit to another orbit, they may emit or absorb energy. Thus, Bohr explained the stability of nucleus. That's it, my dear students. So, for your homework part, let us do a small activity. In a chart, show both Rutherford model and Bohr model by sticking thread as orbits and crush the old newspapers, okay, and make it as a ball and have it as an electron, okay. Have it as an electron and place a small ball at the center to show nucleus. Can you get it, students? So basically, you're using the thread as orbits. Okay, you need to stick the threads as orbits, crush the old newspaper and make it as a ball and fix it as an electrons. Okay, here there are electrons, right? So for Bohr model, you need to fix this electrons. For Rutherford model, there's only one electron here, so you can fix only one electron, okay? And place a small ball at the center to denote it is a nucleus. Okay, if you have a ball, you can place it, you can stick the ball at the center of the atom, okay, to denote it is a nucleus. I hope you understood, students. Do it in a chart. Divide the chart. One half you do Rutherford model and another half you do Bohr model. Submit it in Google Classroom. That's it, my dear students. Thank you so much. Stay home, stay safe. God bless you.